Today I am here to teach you a grade 9 science lesson. By looking at these pictures, you can guess what the lesson is. Yes, it is reflection of light and sound waves. This is unit 14 in your textbook. The lesson title is Reflection and Refraction of Waves. Let me introduce the competency to which this lesson belongs. Utilizes various forms of energy, their interaction with matter and energy transformations efficiently and effectively. Let us see what the competency level is. Applies the principles of reflection and refraction of rays effectively for day-to-day tasks. To begin with, let me introduce what we are going to do today. We learn reflection of light, ray diagrams to show how the light reflects, laws of reflection, regular and diffuse reflection, reflection by plane mirror and uses of it, reflection of sound, effects and applications of sound reflection, and last, methods to avoid reflection of sound during this lesson. How do we see things? We see things because of reflection of light. In this diagram, you can see light ray is coming from the sun, the main source of light we have, and light ray is falling on the object. Here it is a tree. So, light ray that is reflected from the tree is reaching the ear of the observer, so that she can see the tree. In this way, we can see the things around us. What happens when light is incident on an object? Part of the light can be reflected by the surfaces. We call it reflection. A part of light can be transmitted through it. We call it refraction. A part of light can also be absorbed. We call it absorption. Amount of light that absorbed, reflect or transmit depends on the material from which it is made up of. If the object is opaque, most of the light will be absorbed or reflected by the object. And if the object is transparent, light is transmitted through it. That is, light passes through the object and go out of it in the other side. When light is absorbed by the object, light is not reflected or transmitted, but it remains inside the object itself. So, can you give some examples for these things? Mirror surface reflect most of the light from it, and glass is good example for transparent object. So, it transmits light through it. Not only glass, air and water to transmit the light through it. So, black objects are good absorbers of light. Sometimes two of these or all three can happen together in one object. Let us move on to the features of light. Light is composed of very thin light rays. This is one light ray. So, light ray is represented by a straight line, and the direction to which it travels is represented by the arrow head. A collection of light rays is known as a beam of light. There are three types of beams: parallel beam, divergent beam and convergent beam. In parallel beam of light, you can see light rays are travelling parallel to each other. In divergent beam, light rays are spreading out. On the other hand, in convergent beam, you can see light rays are collecting to one point. The next feature of light is it travels in straight lines. Here you have a picture of an activity done by a student in your grade. In this activity, they used 3 cardboards with holes in it. In this picture you can see they kept these cardboards in a line. So, other side of the cardboards you can see a lighted candle. So, observer is in this side. So, when you observe through the holes, you can see the candle light. But next, if you change the position of one cardboard, will you able to see the candle light? No, it is because the light travels in straight line. Next feature of light is it travels through vacuum or transparent medium. And at last, when light strikes on a reflecting surface such as mirror, it reflects. This diagram shows a light beam is directing from a light source. Light source is the object that gives out light. So, here a torch is directing a beam of light on the mirror, and the mirror reflects the beam of light as parallel rays. So, now we are going to see how the light is reflected by plane mirror. So, first we will see reflection of an inclined ray of light. So, this light ray is inclined on the plane mirror, so that you can see the reflected ray of light. Next is reflection of an inclined beam of light. So, this torch gives out a beam of light. You can see that beam is reflected as a parallel beam. Now, both above instances, light ray is incident at an angle. So, we use inclined rays. But what happens if a light ray falls perpendicular to the mirror surface? So, here you can see the light ray is falling on the mirror perpendicular to it. So, you can see the reflected ray is also travelling in the same pathway. So, you can see the incident ray and the reflected ray both are in same line. So, if light ray falls perpendicular to the mirrors, it reflects back in the same pathway. Let us watch a video to learn this more. This activity shows the reflection of light. So, first you have to draw a straight line using a pencil. Then keep the plane mirror on the line perpendicular to the white sheet. Next, direct a ray of light to the plane mirror and trace the light ray that is falling on the mirror, and trace the light ray that is bouncing back from the plane mirror. Then draw the two light rays using a ruler. Then keep the protractor and mark the line that is perpendicular to the mirror surface, so that you can measure the angles in either side of the perpendicular line. You can see the both angles are equal and it is 35. So, you will come up with a diagram like this. Let us see what is in this diagram. Incident ray, reflected ray, the line that is perpendicular to the mirror surface, angle of incidence and angle of reflection. Then you can complete the diagram by drawing the perpendicular line as a dotted line and mark the value of the angles and show the direction of light rays using an arrowhead. Once we have done the activity, you will end up with a diagram like this. This is called a ray diagram. Ray diagram is a diagram that shows the way light rays are travelling. So, let us define parts of this diagram. The light ray that is falling on the mirror is known as incident ray, and the light ray that is bouncing back from the mirror is known as reflected ray. The point on which the light ray is falling is known as point of incidence. The line perpendicular to the mirror surface is known as normal. Angle between the incident ray and the normal is known as angle of incidence, and angle between normal and the reflected ray is known as angle of reflection. Let us see what laws of reflection say. It says the incident ray, reflecting ray and the normal at the point of incidence are in the same plane. Since they are in the same plane, we can get a diagram like this. If they are not in the same plane, you can't draw a diagram like this. In addition to this point, the law of reflection say the value of angle of incidence is equal to the value of angle of reflection. Simply, angle of incidence is equal to the angle of reflection. Reflection is of two types, regular reflection and diffuse reflection. Let us see what the regular reflection is. When parallel light rays are falling on an object, if they are reflected parallel to each other, we call it regular reflection. Regular reflection is done most of the time by smooth surfaces, for example, plane mirror. You can see a beam of light directing on a plane mirror is reflected as a parallel beam of light. And this is an example to show the regular reflection by a plane mirror. So, let us define what the diffuse reflection is. Unlike regular reflection, in diffuse reflection, when the parallel rays are falling on an object, they are not reflected as a parallel beam of light. Instead, they are reflected into various directions. This diagram shows it. Here you can see light rays are falling on an irregular surface. So, you can see the reflected light rays are reflecting into various directions. They are not parallel to each other. The direction to which these rays are reflected depend on the point where they fall. All these rays follow the law of reflection, so that you can see these light rays are reflected into various directions according to the law of reflection. Diffuse reflection is done by rough surfaces, for example, aluminium foil and other objects like books, plants, earth. We too reflect light as diffuse reflection. This is an example to show you how the diffuse reflection is done by aluminium foil. Let us move on to see the instances where regular reflection is useful. When using mirrors, that is what you all are doing every day. When you look at your face every day using a plain mirror, you use regular reflection. To create vivid light patterns in Christmas decorations, in musical shows, in Vesak decorations, you may have seen lot of light decorations. All these light decorations are based on regular reflection. You can see some light decorations here. In addition to that, regular reflection is useful to get information about the motion of machine parts in industrial plants. Not only regular reflection is useful, diffuse reflection is also useful for us. We see the objects in the environment because of diffuse reflection. You can see here a tree, a parallel beam of light is falling on the tree. This is an example for diffuse reflection. You can see a parallel beam of light is falling on the tree. So, the reflected rays are not parallel to each other. They are reflected to various directions. Because of that, we can see the object three-dimensionally. In addition to that, letters in a book can be seen because of diffuse reflection. So, let us move on to the characteristics of images formed by plane mirrors. Here you can see an object is in front of a plane mirror. This is the plane mirror and this is the object in front of it. So, the light rays that are coming from the object striking on the plane mirror and reflected and reach the eye of the observer. So, if you extend these light rays reflected from the mirror, you can get the image here. It is obvious that this image is virtual. What is meant by virtual? Virtual is you can't get it into a screen. The image is upright too. Next, it is obvious that size of the image is equal to the size of the object. And also the object distance and image distance are equal. Object distance is the distance between the object and the plane mirror. Image distance is the distance between the plane mirror and the image. So, when you see through the plane mirror, another characteristic of image is lateral inversion. Let us see what the lateral inversion is. Let me introduce two letters of English alphabet to explain what the lateral inversion is. It is changing the right hand side and left hand side of the image. In this diagram, you can see capital R here in front of the plane mirror. So, when you see through the mirror, you can see R like this. So, it is clear left and right side of the letter has been changed. So, I used another letter D here to show the lateral inversion when you observe through plane mirror. I will give you a small activity. At home, you can find other letters in the English alphabet where you can observe lateral inversion. There is a reason for me to tell like this. All the letters in English alphabet, you cannot see lateral inversion. Do it and find it out. Let us see how to draw a ray diagram of an image of a pointy object in front of a plane mirror. What is meant by a pointy object? Here, the object is like a point. First, you have to place a white paper on a table and fix the mirror perpendicular to it. Next, take a cardboard with a slit and direct two laser beams through the slit to the plane mirror. So, you can see the incident light ray and the light rays that are reflected from the plane mirror. Let us see how to illustrate the ray diagram for above activity. This is the pointy object over here. You can draw the plane mirror like this and then draw the pointy object like this. Then you can draw two incident rays that is coming from the pointy object using a ruler. Then keep the protractor and draw the perpendicular line at the point of incidence to the surface of plane mirror. Then you can measure the angle of incidence and you can measure the same angle as angle of reflection and mark the reflected line. Then use a ruler to draw the reflected light ray. Same way you can draw the reflected light ray to the other incident ray as well. Then using a ruler you can extend these reflected light rays behind the mirror until they meet each other. So, that you will get the point where the image is. That is how you draw a ray diagram for pointy object in front of the mirror. Let us move on to the uses of plane mirrors. So, plane mirrors produce multiple images. Here you can see two plane mirrors are kept at an angle. You can see many images in it. So, multiple images are the images more than one. So, in this diagram there are many images formed by plane mirrors. Next, to observe the back side of a haircut when you are at a salon, you use plane mirrors. In addition to that, to watch our own face, we use plane mirrors. So, these are the activities we are doing in our day-to-day life. For laboratory activities too, we use plane mirrors. And in shops, to show the number of items increase, they use plane mirrors. These things can be seen in jewelry shops and supermarkets. You may have experienced these things in your life. Next, to make kaleidoscope, we use plane mirrors. Let us see how the kaleidoscope is made. To make this, we use three rectangular shape plane mirrors. We keep them in contact with each other at an angle of 60 degrees. We can fix it using a tape and then cover the kaleidoscope using a color paper or black paper or whatever the paper available. One end of the kaleidoscope you can put an oil paper. Then insert some flower petals or some colored pieces of papers inside it and then you can observe from this side. Then you will be able to see a pattern like this. Remember, this is again a multiple images. Then to make periscope. What is periscope? This is a structure of the periscope. This is used by most of the time soldiers inside bunkers. So, while they are hiding in the bunkers, if they want to see outside where the enemy is coming, they use periscope. Periscope is a tubular structure like this, and two plane mirrors are used in this. So, this is the object and here is the soldier hiding inside the bunker. So, a light ray that is coming from the object here reflected once from this plane mirror, and for the second time it is reflected from the second plane mirror and reaches the eye of the observer, so that the soldier inside the bunker can see the objects outside while hiding in the bunker. Not only soldiers, people who travel in submarines use these periscopes to see what is happening above water. With that, we finish the reflection of light. So, children, listen carefully. Now, when you hit a ball to a wall, what will happen? It bounces back to us. As you learnt earlier, if we direct a ray of light to a wall, it also bounces back or else reflected. So, what will happen when we speak? Does the sound also get reflected by the wall? Answer is yes. So, next part of the lesson is reflection of sound. Let me define what the reflection of sound is. Bouncing back of sound from an obstacle is known as reflection of sound. So, sound is reflected when it is striking on a surface. To explain this, I will show you another video. Before go to the video, I will explain what is happening in the video. Here you can see a metal sheet is kept on a tabletop perpendicular to it. At the end of this hollow tube, a stopwatch is kept which give a tick sound, and at the end of the other hollow tube, listener keeps his ear. In between these two hollow tubes, piece of cardboard is kept. That is in order to prevent reaching the sound of tick from this watch directly to the listener. So, let us watch the video and explain it more. This is the metal sheet that is kept perpendicular to this board, and these are the two hollow tubes, and this is the cardboard in the middle. So, when a ticking sound is made, it goes and reflects here. So, you have to change the position of the tube until you get a clear sound. After that, you have to remove this metal sheet and see whether you can hear the sound again. Can you hear the ticking sound when the metal sheet is removed? Exactly no. These are the observations of the video you watched just now. What is an observation? Observation is what you saw in an activity. Here you heard sound when the metal sheet is present at a certain point, and when the metal sheet is removed, sound is not heard. So, what did you learn from this activity? So, we write it under conclusion. So, it is obvious that sound is reflected by the metal sheet, because when we remove the metal sheet, you did not hear the ticking sound of the watch. So, now we are going to discuss two main phenomena of reflection of sound. They are echo and reverberation. So, these are the instances where the reflection of sound can be observed, experienced in day-to-day life. Let us discuss echo first. Echo is second hearing of sound after the first sound due to reflection of sound. Sometimes not only one echo, if the sound is reflected for several times, you can hear several echoes. For example, reflection in an auditorium. Can you hear echo in a small room? No. There should be a minimum distance to hear an echo. So, now we are going to calculate the minimum distance that should be maintained between the sound source and the obstacle to hear an echo. For this calculation, you should know the time period that sense of sound is retained in human ear. So, that is calculated as 0.1 second, that is 1/10 of a second. That means, when you hear a sound, that sound is persistent in your ear for about 1/10 of a second. So, if you need to hear a second sound, you have to have a gap, time gap between the initial sound and the second sound or the reflected sound. That time gap is 0.1 second. And for this calculation, you also need the speed of sound in air. The speed of sound in air is 330 meters per second. So, speed of sound varies with the medium. So, in water it gets another value. So, this diagram shows the observer and the sound source and the obstacle. So, here we use the word observer or sound source because both these are in the same place. To calculate the minimum distance, we need this equation. So, that is distance equals speed multiplied by time. So, you can calculate the distance travelled by sound within 0.1 second. So, it is 330 meters per second is the speed and this is the time. So, you will get the total distance that sound travels as 33 meters. Is this the minimum distance between the observer and obstacle? No. Sound travels from the sound source to the obstacle and reflected back to the observer. So, this is twice the distance between the observer and the obstacle. So, to get the minimum distance between the observer and the obstacle, you have to divide this by 2. So, you will get 16.5 meters. So, that is the minimum distance that should be maintained in order to hear an echo. So, let us see what the reverberation is. So, echo generated by the reflected sound is heard before the initial sound fades away from the ear. As I told you earlier, when we hear a sound that is persistent in the ear for some time, that is 0.1 second. Before the initial sound fades away from the ear, the second sound is heard. Because of that, listener is not able to distinguish the original sound and the reflected sound, that is echo. As a result, listener experienced a mixed, unclear sound. This is what is meant by reverberation. So, this is a really disturbance for hearing. This condition is observed in auditoria, lecture halls and cinema halls. As I told you earlier, reverberation is also due to the reflection of sound. So, what is the difference between the echo and reverberation? In echo, there are two distinct sounds, but in reverberation, the sound is persistent or it's continued. So, if you want to hear a clear sound, you have to minimize reverberation. So, to minimize reverberation, you have to stop or reduce reflection of sound. So, that can be done by absorbing the sound. So, let us see some methods to prevent reverberation. By making the walls rough, making the ceiling porous, and by hanging rough folded curtains, you can allow sound to absorb without reflecting, so that you can get a clear sound. Is the reflection of sound good or bad? What do you think? My answer is both. Echo and reverberation are instances where the sound is disturbed, but there are some applications of sound reflection. Ultrasound scanning. So, this method is used to observe internal organs in the body. Ultrasound waves are generated by a machine and they are aimed at the relevant organ inside the body. So, this is the ultrasound machine and the ultrasound waves aimed at a mother's womb. So, the sound waves that is reflected from the organ is again received by the machine and the machine give out a picture like this. So, this is the fetus inside the mother's womb. Next use of sound reflection is to find the depth of the seabed. The method used here is known as sonar, that is sound navigation and ranging, and the equipment is known as echo sounder. So, this diagram shows a ship traveling in the sea. The echo sounder is fixed at the bottom of the ship like this. So, ultrasound waves are emitted from the echo sounder. It passes through sea water and once it hits the seabed, it reflected back. So, reflected ray is also received by the echo sounder. So, that echo sounder can measure the time taken for the ultrasound wave to go down to the sea bottom and to come back. So, let us see how to calculate the depth of seabed. For this calculation too, you need to know these values. As I told you, the speed of sound varies with the medium. So, speed of sound in water is 1500 meters per second, and time taken for the ultrasound wave to go from the bottom of the ship to the bottom of the sea and to reflect back to the sea is taken as 0.4 seconds. So, for this calculation too, you need the same equation, that is distance equals speed multiplied by time. So, speed here is 1500 and the time taken for the sound wave to travel is 0.4 seconds. So, you will get the answer as 600 meters. So, this is not the depth of the sea. This is the distance travelled by ultrasound wave from the bottom of the ship to the bottom of the sea and from the bottom of the sea to the ship again. So, to get the depth of the sea bed, you have to divide 600 by 2, so that you will get the depth of the sea as 300 meters. So, using sound reflection, you can find the depth of the sea. Third use of sound reflection is for bats. They use ultrasound waves to find the obstacles at night. Ultrasound waves emitted by bats reflect after bouncing on the obstacle, so that bat can identify where the obstacle is and they can avoid the obstacle and fly at night. So, with that we finish the reflection of light and reflection of sound. So, I hope you all understood the lesson. Let us do some questions to revise the lesson we have done today. Question number 1. You have to put tick to correct statements and cross for the incorrect ones. First statement, angle of incidence is not always equal to the angle of reflection. Is this correct? No. Laws of reflection say that angle of incidence is always equal to the angle of reflection. So, this statement is wrong. Second one, light rays that are falling perpendicular to a plane mirror do not get reflected. This statement is also wrong. As we learnt, the light rays that are falling perpendicular to the plane mirror reflected in the same pathway. Regular reflection occurs well from rough surfaces. Is this correct? This also wrong. Regular reflection occurs well from smooth surfaces. Cause for reverberation is not the echo. It is also wrong. So, cause for reverberation is echo. Reverberation can be minimized or eliminated by preventing the reflection of sound. Yes, it is correct. Question number 7. Echo can occur at any distance between the observer and the obstacle. That is wrong, because we calculate there should be a minimum distance between the observer and the obstacle to hear an echo. Multi-images occur in kaleidoscope. Correct. Reflection of ultrasound waves is used to observe internal organs. That is correct. It is a use of reflection of sound. Question number 2. Write 3 characteristics of an image formed by an object kept in front of a plane mirror. Image is virtual, upright, equal to the size of the object, and we learn 2 more. Object distance is equal to the image distance and lateral inversion occur. If you have written 3 of these things, your answer is correct. Who use periscopes? Soldiers in bunkers and people in submarines. Mention 3 uses of plane mirror. Very easy question. To watch our own face, to show number of items increase in shops, to make kaleidoscope and periscope, and for laboratory activities. These things you know in your day-to-day life. Question number 5 is based on this diagram. I think this diagram is familiar to you now. Question number 1. Write observations of above activity. Answer is sound is clearly heard by the listener at a certain point. Question number 2. Write your observations when the metal sheet is removed. Sound is not heard. Next question is write your conclusion. Your conclusion is sound is reflected from the metal sheet. Why there is a piece of cardboard in between two tubes? That is to prevent hearing the sound directly to the listener. Question number 6. State instances where reflection of sound is applied usefully. That is what we have done at last. Ultrasound scanning to find the depth of the sea, for bats to identify obstacles at night. With that we finish the answers for questions, and before we wind up the session, let me conclude what we have done today. We did reflection of light, reflection of light by a plane mirror, laws of reflection, regular and diffuse reflection, image formed by a plane mirror, uses of plane mirrors, reflection of sound, and instances where reflection of sound is disadvantageous and useful. I hope you understood the lesson and enjoyed it well. Please refer Unit 14 in your textbook and do some past papers as well. You can watch this video through YouTube channel NIE, and we will meet up again with the next part of this lesson, refraction of light. Have a nice day.